Welcome to Cosmic Compass, where together we explore the most fascinating worlds in our solar system. Today, we set our sights on Titan, Saturn's largest moon, and one of the most mysterious places we know. Imagine a frozen world with mountains capped by methane snow rivers, carved not by water, but by liquid hydrocarbons, and a thick orange atmosphere that hides everything beneath. Titan is both alien and strangely Earth-like, a place where scientists wonder if life could exist deep below its icy shell. In this journey, let's uncover the secrets of Titan, from its dense atmosphere to its methane seas, its icy volcanoes, and the tantalizing possibility of life in its hidden ocean. Imagine a world where rivers and lakes are not made of water, but of liquid methane, a world wrapped in a dense orange haze colder than Antarctica, yet strangely familiar. This is Titan, Saturn's largest moon, and one of the most intriguing places in the solar system. Titan stands out for three reasons. It is the only moon with a thick atmosphere, it has stable bodies of liquid on its surface, and humanity has actually visited it. Thanks to the Cassini Huygens mission, we have real images and even video footage from its surface. So today, let's embark on a journey to Titan. We'll explore its size, composition, atmosphere, methane seas, and alien geology, and ask what makes this frozen world so fascinating and perhaps even important for the search for life. Titan is the sixth spherical moon from Saturn and by far the largest. To put it in perspective, Titan is more than 50% wider than Earth's moon and about 80% more massive. In fact, it's the second largest moon in the solar system, just behind Jupiter's Ganymede. If you placed Titan next to Mercury, Titan would appear bigger in diameter, though Mercury has more mass because it is made mostly of rock and metal. Titan, by contrast, has a much lower density, about half rock and half water ice. Its surface gravity is only about 1,7 J, meaning you would weigh far less there than even on our moon. Like many large moons, Titan is thought to be differentiated into layers. Beneath its icy crust may lie a hidden ocean of water mixed with ammonia. Cassini provided evidence for this when it detected extremely low-frequency radio waves which could reflect from a subsurface liquid layer. In addition, surface features seemed to shift by tens of kilometres over time, suggesting the icy shell might be floating atop an internal ocean. Could such an ocean harbour life? While we don't yet have proof, many scientists speculate it could contain conditions suitable for microbial organisms. We will need future missions to confirm this, but it keeps Titan high on the list of worlds worth exploring. Titan takes about 15 days and 22 hours to orbit Saturn. Its orbit is slightly eccentric and tilted, but that doesn't mean Titan was captured. Instead, it's believed that Saturn once had several large moons. Most were destroyed in ancient collisions, leaving Titan as the sole survivor of a violent early history. Titan, like our own moon, is tidally locked. One side always faces Saturn, while the other forever looks away. If you stood on Titan and somehow cleared the haze, Saturn would hang motionless in the sky, never rising or setting. From Saturn's perspective, Titan is just one of many moons. But from our perspective, it is extraordinary, a world with its own weather geology and surface liquids. Perhaps Titan's most striking feature is its atmosphere. When astronomers first saw images of Titan wrapped in a dense haze, it was easy to mistake it for a planet. Titan's atmosphere is thicker than Earth's, with a surface pressure about 1.45 atmospheres. That's 45% higher than what you feel at sea level here. It extends far into space, up to 600 kilometres, compared to Earth's mesosphere that ends at about 120 kilometres. The atmosphere is made of 98% nitrogen with methane and trace amounts of hydrogen. Sunlight breaks down the methane in the upper atmosphere, producing hydrocarbons that form the thick orange haze we see. But here's the puzzle. Methane should disappear in just 50 million years a blink. compared to the solar system's age. So where is it coming from? Possible sources include cryovolcanoes, where subsurface liquids erupt to the surface, or perhaps even biological processes. If you stood on Titan, the sky would be a murky orange. Sunlight reaching the surface is just 0.1% of what we get on Earth, dim as a deep twilight. Temperatures average 183 degrees. Oxygen would be absent, so you'd need a breathing mask, and you'd need heavy insulation against the cold. Still, Titan's thick atmosphere provides protection from radiation. Of all moons, it feels oddly like a world you could imagine visiting, hostile but strangely Earth-like. Nowhere is Titan's similarity to Earth more striking than in its methane cycle. On Earth, water evaporates, forms clouds and falls as rain. On Titan, methane takes that role. Titan has methane clouds, methane rain, and methane rivers that flow into methane lakes and seas. When the Huygens probe descended through the atmosphere in 2005, it landed on what looked like a dried up lake bed with rounded pebbles shaped by past liquid flow. From orbit, Cassini confirmed that Titan hosts true lakes and seas. Ontario Lacus near the South Pole covers about 15,000 square kilometres. Jingpo Lacus reflects sunlight like a giant mirror. Ligeia Mare in the north is larger than Lake Superior, with depths over 200 metres, and the crown jewel Kraken Mare spans 400,000 square kilometres, larger than all of Earth's Great Lakes combined. These seas are not static. Cassini even spotted the mysterious Magic Island, a feature that appeared and disappeared in Ligeia Mare. Was it bubbles rising from below ice chunks or waves? We still don't know. What we do know is that Titan is the only world besides Earth with stable surface liquids. For the first time, humanity has found alien seas, and one day, perhaps, we will sail them. Titan's surface is geologically young, estimated at about 100 million years. That means it is still being reshaped. One of the key processes may be cryovolcanism. On Earth, volcanoes erupt with molten rock. On Titan, the lava may be slurries of water and ammonia erupting from cryovolcanoes. These flows would freeze instantly, but could spread across the surface, creating broad domes and plains. The most promising candidate is Sotra Patera, a feature in Titan's southern hemisphere with a deep pit 1.7 kilometres across. To create such a feature, enormous forces must have been at work. While it shows no current activity, scientists monitor it closely. Huygens also revealed that Titan's surface has the consistency of wet sand or crusted snow. Imagine walking across a frozen surface that holds your weight gently, but gives way if you press too hard. Mountains on Titan include ranges like Mithrim Montes, reaching 3,300 metres capped, not with water ice, but with methane snow. The alien geology makes Titan feel both familiar and utterly strange. Titan's landscape is diverse. Cassini's instruments revealed vast plains, canyons, and enormous fields of sand dunes. These dunes, stretching hundreds of kilometres, resemble those in Earth's deserts shaped by Titan's steady winds. Dark regions on Titan were once thought to be seas, but Huygens showed them to be plains of dark organic material. Over millions of years, hydrocarbons settle from the atmosphere coating the surface. Between the lakes, dunes and mountains, Titan looks like a frozen version of Earth, an echo of our own planet's early past. When we look at Titan, we see a world that mirrors Earth in eerie ways. It has an atmosphere, weather rivers, seas, mountains, and maybe even volcanoes. But where Earth is warm and filled with water, Titan is frigid and ruled by methane. Titan may represent what Earth once looked like in its early stages before life reshaped our planet. Studying Titan can give us clues about Earth's past and the possibilities for life elsewhere. Cassini and Huygens gave us extraordinary insights, but they were only the beginning. No spacecraft has ever orbited Titan directly. Future missions, perhaps a drone or even a submarine could change that, exploring Titan's seas and unlocking its secrets. Until then, Titan remains one of the most captivating and mysterious places in the solar system. It reminds us that worlds can be familiar, yet profoundly alien, and that the universe still holds countless wonders waiting to be discovered. Titan challenges our imagination. It looks like Earth in many ways, yet it runs on a completely different chemistry. Where we have water, Titan has methane. Where we breathe oxygen, Titan suffocates in nitrogen and haze. And where Earth is vibrant with life, Titan leaves us wondering, could it hide something beneath its icy crust? Cassini and Huygens gave us our first glimpse, but much remains unknown. One day, perhaps, we will return with new missions, drones soaring through Titan skies, or even submarines diving into Kraken Mare. Until then, Titan remains one of the most compelling mysteries of the solar system. If you enjoyed this journey with Cosmic Compass, don't forget to subscribe, share, and join us again as we continue exploring the wonders of the universe, one story at a time.